Okay, so we're going to go ahead and get started. So today we're working on, oops, hold on a second. Take it back. Okay, so today we're working on quiz 4.1. And then we need to cover chapter 4, the ors and ands a little bit more, and also I need to try to get to at least one, because that's kind of a hard concept you guys are going to want to kind of get a handle on for a while. Today we have Do Connect Math, your second one for chapter 2. And then also, on Thursday, you'll have your first Connect Math for chapter 4 due. Sunday, you have one due Sunday. That way they're spaced out a little bit more. So Thursday and the next one Sunday, you have your next chapter 4 homework due. That one's a little bit tougher. So if you have questions about that one, don't spend tons of don't spend more than a couple hours working on that one. If you try a problem for a while, if you get stuck, move on, and then you can ask about it on Monday. You only lose 1% doing those problems on Monday, which is it's not very much. So rather than wasting a ton of time, spend maybe 10 minutes on a problem, but don't spend hours and hours on a problem. And then next Tuesday, 4.4 is due. Ideally, even better, try to get to these before class on Thursday, so then you can come into class on Thursday with questions. Then you wouldn't have to worry about them being a day late. The exam is on next Thursday. Don't forget to connect up quizzes, which are due the day after each of these homeworks. It's basically, again, it's just 2 problems from the homework, usually, just to prove that you know how to do it without using the help buttons. So knock those out finish your homework, and then knock those right out right away. Exam 1 on chapters 1, 2, and 4 is next Thursday. We do not have class next Tuesday. I will be here. I will do an optional review session. So you feel free to come on in. I'll be here. Our tutor will be here. So Victoria will be here, and we'll answer questions and stuff like that. I'll probably do sort of a kind of a formalish sort of review session for the first hour and a half, and then just whatever help you guys need. We'll be here to answer questions and stuff like that. Okay. Whoops, that's still wrong. Sorry. So this is going to be on Thursday, October 7th. It's going to cover chapters, again, like I said, chapters 1, 2, and 4. The study guide is over there. The study guide is the very best way to prepare for this exam. It has questions similar to the questions you're going to get asked on the exam. Someone asked a great question, which is, on the exam, will we have paper and space like we do for the quizzes to answer it? Yes. So all the work's going to be done on the quiz itself. You just are on the exam itself. You get a question, you have space to answer it, just like we have in class. You should bring a pencil or 2, an eraser. You get a half page of notes, an 8.5 by 11 piece of paper, not some ginormous piece of paper, 8.5 by 11 piece of paper, a half page, one-sided. So what you can do is you can take a blank paper, and you'll get a half page for each exam. So you can do a half page for your first exam, a half page for your second exam, half page for your third exam, and then a half page for the final. And you can have it all on one sheet if you want. Because I can tell, as I'm looking through your stuff, I can tell which stuff is exam 1 material notes and which one is exam 2 material notes and so forth. I know the difference between them. So you can put that all on one paper, or you can do 4 separate pieces of paper too. It's fine. Either way is good. You should also you might want to bring blank scratch paper, possibly if you feel a need for that. But you should show all your work on the exam, pretty much. Like anything you want credit for. Like all your things you multiply or divide or subtract, I want to see that on the paper. If you draw like I'll have you draw a tree, that's going to be on the exam, right? You should draw that on the exam. You should bring a basic calculator. You see a basic calculator that multiplies, divides, adds, and subtracts. That's all you need for this one. And bring your binder in order. So you have 2 sections of the binder. One is going to be your quizzes, all in one section, in order, completed and corrected. And then you're going to have a second section of all your notes. Again, complete and in order. You can get up to 2 points extra credit for that. No cell phones are allowed, so make sure those are on silent and in your bag. No smartphones, no ear stuff, ear gear, none of that other stuff. So all that stuff should be off in the bag, right? Put away. Good. Any questions? Questions? No? Okay. Right. Believe it or not, most published research findings are probably false. So, remember a while ago I talked about how samples, just randomly, once in a while you're going to get an unusual sample and not know it, right? That's going to happen. Our guideline for unusual is, what's our guideline for unusual? Anybody remember?
0.
Yep. Yeah, 5% or less, 0.05 or less, 5% or less. So that means that randomly, there's a whole bunch of possibilities. 5% of the time, you're going to get something unusual, just because that's how probabilities work, right? Just things that happen only 5% of the time are considered unusual. So 5% of the time, you're going to get an unusual sample and not know it. So what happens is people do all these experiments, and say you do an experiment for something that's not true. Like, I don't know, I think that a coin, true value of a heads is not 50%, it's really something larger than 50%. So a bunch of people do experiments to try and prove that, and most of the time, 95% of the time, they don't get anything unusual, and they're like, oh, yeah, I was wrong. I guess the probability of heads really is 50%. But 5% of the time, you're going to get a weird sample without knowing it. And those 5% of the people are going to write a paper and get published. And then, if someone tries to reproduce that, they won't be able to, because it's not that what they're saying is really true, it's that they just got an unusual sample without knowing it. So I'm going to show you guys a video, and it talks about that a little bit. It's kind of cool, but it also talks about like other gross misappropriations. Like this. Just bigger. And start it.
All of this was pointed out in a 2005 paper entitled Why Most Published Research is False. So recently, researchers in a number of fields have attempted to quantify the problem by replicating some prominent past results. The Reproducibility Project repeated 100 psychology studies, but found only 36% had a statistically significant result the second time around. And the strength of measured relationships were on average half those of the original studies. An attempted verification of 53 studies considered landmarks in the basic science of cancer only managed to reproduce 6, even working closely with the original study's authors. These results are even worse than I just calculated. The reason for this is nicely illustrated by a 2015 study showing that eating a bar of chocolate every day can help you lose weight faster. In this case, the participants were randomly allocated to one of 3 treatment groups. One went on a low-carb diet, another went on the same low-carb diet plus a 1.5-ounce bar of chocolate per day, and the third group was the control, instructed just to maintain their regular eating habits. At the end of 3 weeks, the control group had neither lost nor gained weight, but both low-carb groups had lost an average of 5 pounds per person. The group that ate chocolate, however, lost weight 10% faster than the non-chocolate eaters. The finding was statistically significant with a p-value less than 0.05. As you might expect, this news spread like wildfire to the front page of Bild, the most widely circulated daily newspaper in Europe, then to the Daily Star, the Irish Examiner, the Huffington Post, and even Shape magazine. Unfortunately, the whole thing had been faked. Kind of. I mean, researchers did perform the experiment exactly as they described, but they intentionally designed it to increase the likelihood of false positives. The sample size was incredibly small, just 5 people per treatment group, and for each person, 18 different measurements were tracked, including weight, cholesterol, sodium, blood protein levels, sleep quality, well-being, and so on. So if weight loss didn't show a significant difference, there were plenty of other factors that might have. So the headline could have been chocolate lowers cholesterol, or increases sleep quality, or something.
Right, so basically what they did was they just searched around until they found something that was unusual in their sample, and they were able to write a paper about that. Does that kind of make sense? Like just randomly, it's going to be something's going to be unusual. So again, another reason why you should mistrust any sort of study done by someone who's biased, who has a good reason to want to have a positive outcome, right? Okay. So let's go ahead and look into this idea of things being unusual. So I want you guys to all bust out your phones or your computers, either one, and Google. We're all going to flip a coin 100 times. So every one of us is going to flip a coin 100 times. So, but we're going to do it electronically. So Google Rossman Chance applet. Rossman Chance applet. One prop. That'd be easier if you did one prop also. I'll do it. Rossman. I'll make it bigger. Great. Rossman Chance applet one prop. And looks like this first one will work. There's also this one here, exact one proportion inference. Either one of these will be it, but you'll end up getting this right here. Looks like that. Is everybody there? If you're not there, raise your hand and we'll help you get there. If you're having trouble, raise your hand. There's two of us here who can help you out. Rossman Chance one applet one prop. Chance applet. Oh, so you guys all have it? Yeah, the Apple phones do weird. They're just strange. I don't know. They do it. You get here, but you get here a little bit harder. Now, Rossman Chance, space, Chance. So if you do applet collection, that's okay. Let's get to the one that says one proportion. Get one proportion inference. One proportion. Yeah, so if you get applets, just find the one that says one proportion. That's all good, and that should take you to here. Everybody here? All right, good. So we're going to flip a coin. Probability of heads is 50%. How many times are we each flipping it? 100. So change this to 100. Everybody on board? This should be 100. Change it to 100. Now I would unclick the enemy because otherwise it's going to take a long time, or it'll take longer. No one draw your sand. Okay, I got 45 heads. It gives you a summary stats that tells you how many you got. Should tell you how many heads you got. Did anybody get 59 heads or more? You did?
Oh, you said 59.
Or more. What'd you get?
I thought you said 49.
Oh, no one got 59 or more?
Oh,
Yeah, how many did you get?
57.
57? Did anybody else get in the 50s? Anybody get, no one got 59 or more?
No, 53.
53? Did anybody get 41 or less? What'd you get?
39.
39. So she would write a paper, she'd say, oh my gosh, it's not 50%, it's actually less than 50%. It's closer to 39%. She got something that would be statistically significant in the other direction. Does that make sense, folks? So she would write a paper, and then any of us would try to reproduce it, and we would not be able to. Does that make sense? Because it's a proportion of heads really less than 50%, like 39%? No, it's really 50%. So that's what happens. Is usually it's roughly like 1 out of 20, typically, that will get something unusual. This has been an unusually not unusual group, but that's kind of where this comes from. So, you know, we all do it. We all do our different experiments, and one of us gets an unusual sample, and then writes a paper and gets published based upon that. Okay, good. Let's talk a little bit more about some other stuff. Sample space. You guys remember that? It's a set of all possible outcomes for an probability experiment. Right? So if I roll a dice, My sample space is 1, 2, 3, 4, 5, 6. So let's take a look at quiz number 1. This is what it should look like. This is your sample space over here. Right, that's your sample space. Yes? Good. So I'm going to check your answers. What is the probability of getting exactly 2 tails? Not at least 2 tails, not, more than 1 tail, exactly 2. Not 1, not 3, not 0, exactly 2. 3 out of 8, right? Because there's 3 of them. 1, 2, 3. Successes out of 8 possible, right? There's 8 of them. Good? Okay. What's the probability of getting no tails? What's no tails mean?
All heads.
All heads.
1
1 out of 8. One success out of 8 possible. How about at least 1 tail? Which one of these is at least 1 tail?
7.
Yeah, all these guys have at least 1 tail in them, right? Everybody on board with me? Okay? 7 out of 8. Are these 2 groups related? No tails and at least 1 tails, are they related in some way? Are no tails and at least 1 tails related in some way? That's the question I'm trying to ask here. So I want to talk to your neighbors about it for 15 seconds. All right, so who has an idea of how they're related? Yes, what do you think?
They're mutually exclusive.
They are mutually exclusive. They have nothing in common. What else about them? Yes?
They're complements.
They're complements of each other. So complements of each other have to be mutually exclusive from each other. They have to have nothing in common. And together, they make up the entire sample space. So because they're mutually exclusive, then together they make up the entire sample space. They are complements of each other. They're complements with an E. Right? Complement, like, like when the girl stands up and who is it? The guy says, it's Tom Cruise when he's doing that. He's like, you complete me, right? Complements complete each other. Complete, and then ments instead of eat. Right? Complete. Complements. All right, they complete each other. All right, an event. That's a specific outcome or set of outcomes. Right, so like last class we found the set of outcomes getting a total of more than 9, 10 or more when you roll 2 dice. That's an event. Or it could be, getting 2 4s when you roll 2 dice. So that's another event. Right, there's lots of different events out there. Depends on which one you're looking for. And then remember, probably an event when all events are equally likely. Is it equally likely when I get on a plane, either I crash or I don't crash? Are those events equally likely? There's only 2 possibilities. No, they're not equally likely. Otherwise, people would never get on a plane. So we're not talking about stuff like that. We're talking about when events are equally likely. Like I have you pick a number from 1 to 10 randomly, right? That's, so and I choose a number from 1 to 10, I randomly pick one. All of them are equally likely. That's what we're talking about here. Or you have marbles, you draw one randomly. Okay, so here, when it's random like that, the probability of an event occurring is the number of successes divided by the total possible outcome. Right? So that's something that's kind of key to kind of keep in mind, that kind of carries through everything. So your quiz problem number 2, 20 lab puppies in a store. The probability that you randomly pick a yellow lab or a chocolate lab, what did you guys get for that?
14 out of 20.
Yeah, so yellow, chocolate, they're mutually exclusive. They have no overlap. Oh, sorry. Thank you. Thank you. There. 8, so you can just add the probabilities. 8 plus 6 over 20. 14 over 20. Good? I'm fine with you leaving it like that. You don't have to simplify it. Probably pick a female lab or a black lab. Yeah, 11, 20. Are these ones mutually exclusive? No, they're not. They have some overlap. So, female, 8, black, 6, but they have overlap. You have to subtract out the overlap. So 6 plus 8 minus 3, because that 3 is getting counted in the 6 in the total for black. It's getting counted in the 8 in the total for female, so it's getting double counted. It's getting counted twice. So subtract it off once, you're only counting it one time. So 6 plus 8 minus the 3 over 20, 11 over 20. Probability, you randomly pick a male given it's yellow. So given means now you have some information. It's not out of all of them now. Now it's just out of the yellow ones. You know it's a yellow puppy. If you know it's a yellow puppy, what's the probability that it is male? 4 out of 6. Yep. So again, given is the only time it will not be out of the total. Because given means you have some information. It's not out of everybody. It's out of a smaller group. So the only time your denominator is not everything is when you have given. And then the last question was, are what two things? Yellow and male and yellow. Are those mutually exclusive or not? No, they're not mutually exclusive. Why? You can be at the same time, yeah. You can be both. Right? You can simultaneously be a yellow lab and a male lab. Good? Okay. All right. Great. Next one. Next one I brought up because, despite the fact you guys paid a fair amount for your textbook, they apparently could not afford to put lines in here. So we just put lines in here. Then personally, I think it's way clearer. Right? That's just like the puppies. It's exactly like the puppies when you do that. So I'm going to give you guys a minute or two to finish these up with your neighbors. So now that you have these, you can find your totals along the sides and the bottoms, and you can sort this out. This is on your homework, so just, be aware of it. And they want it in 3 sig figs. Oh yeah. So your homework's going to ask for that as well. All right, so let's see what we got. What do we have for our totals here? We got 4, 10, 18, 6, 26, and 32. Is that right?
Yeah.
Okay, great. What's probably someone's a pediatrician?
10 out of 50.
Yep. 10 out of 32. What about being an orthopedist or an MD? So orthopedists, that's these guys. MDs, that's these guys. So, yeah, so one first thought is, well, maybe it's like if I add 18 plus 26, I get 44 out of 32. Can you have 44 out of 32 people be something? That's more than 100%. So that can't be right. What's up with that?
They're not mutually exclusive.
They're not mutually exclusive, which means that what?
They're overlapping.
There's overlap. I got to subtract the overlap. What's my overlap? 15, I gotta subtract the 15. So then that becomes what? 29 out of 32. There we go, that makes sense. Good? All right, yes?
I just want to say that I find it easier just to add like
Totally.
15 plus 3, and then you look
Totally.
at the column, and then plus 3 plus 8. So you don't have to think about subtracting.
So what she's saying is, orthopedists, just add them, MDs, just add them, and then just do this. 3 plus 8 plus 15 plus 3. You can totally do that also. Absolutely 100%. Good? Out of 32. As long as you have the table. Right? Tables give you all sorts of options. If I want to find some, probably somebody is an MD and pathology, I can just grab that number, 3 out of 32. I don't do any multiplication at all, which we're going to learn about later on today. Okay. Quiz problem 4 from the homework. Aha. Okay, so let's get a reader for this one. How about Michaela? Go ahead and read for me.
A pizza restaurant sold 25 cheese pizzas and 19 pizzas with one or more toppings. 14 of the cheese pizzas were eaten at work, and 11 of the pizzas with one or more toppings were eaten at work. Choose a pizza at random. What is the probability that it was a cheese pizza not eaten at work?
Perfect, thank you. All right, good. So, there are 2 things I know about every pizza. Talk to your neighbors for 15 seconds. Figure out the 2 things I know about every pizza. What are they?
And then we know the ones that weren't
Be 11 out of 25. No, you know the toppings, which ones were eaten at work.
Yeah. Oh, okay, so there's every pizza, I know 2 pieces of information about it. Right? What's one thing I know about every single pizza? What's one thing I know about every single pizza?
What's on the pizza?
What's on it? Whether it's a cheese pizza or whether there's toppings on it. What's the second thing I know about it?
It was eaten at work.
Where it was eaten, at work or not at work. So it makes sense? So I'm going to put one of those across the top. So what's my first thing? Cheese or toppings? So I'll put those across the top. Cheese. So figure out what your options are. Put one of them along the top, and then the other options go along the side. What are my other options? The other thing I know? Work or no work? Not at work. Those are the things I know about each pizza. Now you have your table, right? That's how you set up your table. You figure out two things you know about each pizza. Put one of your options along the top, one of your options along the side. And then, from here, you can figure out you've got 4 numbers that they gave you. 25, 19, 14, 11. Figure out where they go in here. So everybody do that, and then answer your questions. And we also know that 11 pizzas with 1 or more toppings were at work. So 1 or more toppings, work, that should be 11. Good? Now, if I have these 4 pieces of information, I can find these guys here, right? So find those. If there were, let's see, 25 total, that means 14 at work. That means there has to be 11 not at work. 19 total, 11 at work. That means 8 not at work. And I can just add up to find these totals over here. 25, 19, 44. It's unfortunately symmetric, which is kind of annoying, but nothing you can do about that. Okay. So probability that is a cheese pizza not eaten at work. Cheese not at work. Do you see the word given in there? No, there's no word given. So this means it's out of 44. It's out of all of them. So cheese and not at work. How many were cheese and not at work? 11. 11 out of how many? 44. Good? Everyone gonna be good with this problem in the homework?
Yeah.
All right. Okay, so some probability rules. First rule, probability of any event E is a number, and probability of any event is from 0 to 1 or 0% to 100%. 1 is the same thing as 100%. 100 cents is 1, right? $1. A probability cannot be negative, and it can't be more than 100%. Second rule, the sum of all the probabilities of a sample space, if you add them all up, has to equal 1 or 100%. Good? Okay, the other thing we talked about was complementary events. So two events are complementary if they add up, well, okay, that's not, the complementary event E, denoted by E bar or E with a little C over it sometimes, is everything that's not in E. All right, so either you ride a bicycle or you don't. Either you own a dog or you don't. Right? Either you like to camp or you don't. Those are complements. It's either or thing. So it means that their probabilities how darn well better add up to 1 or 100%. Because either you're in E or you're in not E. And so the probabilities of those two, people have to be in one group or the other, they have to add up to 100%. That also means that if you have probability of E, if you have probability of not E, you can subtract that from 1 to get the probability of E. Sometimes that's easier. So write those into your notes if you did not yesterday. They're at the bottom of page, one of your pages, under complements. Most of you guys wrote them in there yesterday because I directed you to, but some of you may not have. Where are they? Oh yeah, where it says complements at the bottom of the page, bottom of the third page. Most of you guys wrote those rules in there yesterday, but if you didn't, write them in now. All right, bottom of this page. Yeah. Bottom of the third page. Did not write those rules in, write them in now. They are super important. 15 more seconds. Okay, so take a picture if you need it. So I'm moving on. All right, grab problem number 5. Do it. A box. I have a box that contains a $1 bill, a $5 bill, a $10 bill, and a $20 bill. Just those 4 bills, one of each. That's it. I'm going to draw one. I'm going to keep it. I'm not going to replace it. And then I'm going to draw another one. And that's it. I'm stopping. I'm only drawing 2. That's it. I'm not drawing all of them. I'm going to draw one, keep it, and then draw another one. That's it. Draw a tree for that. How many possibilities are there for the first draw? 4. Once I draw one and I keep it, how many possibilities are there for the second draw? 3. Good. All right. And then find the sample space. So the sample space would be blank, comma, blank. Just 2 draws. That's it.